43 from chapter 15, it says this equilibrium is established and has a value of k equaling 2.19 times 10 to the negative 10th. And then it says, are the following mixtures of the same things at equilibrium? If not, indicate the direction of the reaction that it must proceed to achieve equilibrium. So what we're finding is the reaction quotient, or Q, because we don't know if we're at equilibrium or not. This is still equal to products, so CO raised to the first power times Cl2 raised to the first power divided by reactants COCl2 all raised to the first power. But now we're going to find it with different values, or with values that might or might not equal K. And then to find out where it should go, remember we write this number over 1 and we ask, is the number that we get have to get bigger or larger to achieve the product's concentration value here on the top? So let's put in the numbers here for letter A. The products are CO 3.3 times 10 to the negative 6th times chlorine, which is 6.62 times 10 to the negative 6th, divided by the reactant, which is 2 times 10 to the negative 3rd. And all those would be the first power, because all these are in the first power if we wrote the equilibrium constant expression correct. Calculating these in letter A, we end up with 1.1 times 10 to the negative 8th. So Q now, if we write this, has a larger number on top than what K does. Q is larger than K. And so to get this to look like this, what do I have to do? Well, this number has to get smaller to look like this. And that means that since it is products on the top divided by reactants, that means that the products need to get smaller. So that means we need less products to achieve equilibrium. And so we'd say that the reaction has to go from the products to the reactants. And so we say the reaction has to shift toward the reactants. Or what we could also say is shift left. That would be another way of saying that. So it needs to shift towards the reactants to achieve this number right now, because right now it's at this. All right, letter B then. Now we take these numbers and put it into this equilibrium constant expression. And so on the top, we'd have 1.1 times 10 to the negative 7th. And we'd also have 2.25 times 10 to the negative 6th. And then on the bottom, we'd have the 4.5 times 10 to the negative 2. And then when we plunk those numbers in our calculator, we end up with 5.5 times 10 to the negative 12th. And so this number now, when we write it over 1, the top here is smaller than the top here. And so our products are smaller than what is needed to achieve K. And so in this case, we'd want to increase this number. And so we'd say the reaction would shift to the right, or shift to the products to achieve equilibrium, because we've got to get this number to look like this number, and to do that it's got to get larger. Lastly, in letter C, we'll put these numbers in, and so then on the top we'd have 1.48 times 10 to the negative 6th times itself, because it says both of them are equal to each other, and then divided by the reactant, which is 0.01, and when we punch those into our calculator, we get 2.19 times 10 to the negative 10th. This is now equal to this, and so we are at equilibrium. And so there will be no shifting. It will just remain the same reactants and products. It's 43.